Okay guys, for this next piece, Learning Target 4 talks about exterior angles. So we're going to watch a video here quick about exterior and interior angles, and I'm going to kind of commentate through it because there's some times where I want you to kind of pause and test some things out or talk about some things. So here is a video on external angles.
Welcome to a lesson on the interior and exterior angles of a triangle. The goals are to define interior and exterior angles of a triangle, and then also state several theorems involving the exterior angles of a triangle. The interior angles of a triangle are the angles inside the triangle formed by the sides of the triangle. So angles 1, 2, and 3 are the interior angles of this triangle. The vertices are the points where the sides of the triangles meet. So the vertices are A, B, and C, and vertex is singular for vertices. So we have vertex A, vertex B, and vertex C. The exterior angles of a triangle are the angles that form a linear pair with the interior angles.
Linear pair, guys, is the same as supplemental angles. So they form a line here. You can see the interior and the exterior form a line, which is going to be 180 degrees.
Extending the sides of a triangle. There are actually two sets of exterior angles based upon which sides you extend. What I mean by that, if we take a look at vertex C, notice the triangle on the left here, we extended side BC through vertex C, and notice on this triangle here we extended side AC through vertex C. So if we continue,
do you think it makes a difference? Do you think these triangles are going to be different depending on how you extend the lines? Do you think this angle, this exterior angle, is going to be the same as this exterior angle? Do you think this exterior angle is going to be the same as this one? And then do you think this one is going to be the same as that one? Talk to your partner here. Pause the video and talk to your partner about that. Because actually they are going to be, because if you think about it, let's say this angle here at C is this interior angle is 100 or is 80 degrees. Well, then this exterior angle would have to be 100 degrees to make 180 to get 180. Well, we don't change the triangle. We don't change the fact that this side or this angle is 80, excuse me. So that means this exterior angle is also going to have to be 100. So these are actually all going to be the same. It doesn't matter which way you extend your triangle.
Pattern, you can think of these extensions going counterclockwise, and these extensions are clockwise. So again, if angles 1, 2, and 3 are interior angles, then angles 4, 5, and 6 would be exterior angles for this triangle. Notice they form linear pairs with the interior angles. And looking at this triangle here, angles 4, 5, and 6 would be the exterior angles. Again, they form linear pairs with the interior angles. And it really doesn't matter which sides you extend, because angle 4 is congruent to angle 4, angle 5 is congruent to angle 5, and angle 6 is congruent to angle 6. Let's take a look at a couple of example problems. Here we want to determine the measure of the indicated angles.
Here, guys, I'd like you to pause the video and just talk to your partner. How do you think he's going to find angle 1, angle 2, angle 3, and angle 4? Don't actually do it, but how do you think he's going to do this?
So there's a couple things to remember. First, the sum of the interior angles of a triangle will always be 180 degrees. And now we also know that the exterior angles form a linear pair with the interior angles. So looking at angle 2, we know the measure of angle 2 plus 138 degrees must be equal to 180 degrees because they form a linear pair. So if we subtract 138 from both sides of this equation, we know that the measure of angle 2 must be 42 degrees. And in a similar way, the measure of angle 1 plus 94 degrees must equal 180 degrees. So if we subtract 94 from both sides, the measure of angle 1 will be 86 degrees. And now looking at the interior angles, we know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must equal 180 degrees. Well, the measure of angle 1 is 86 degrees. The measure of angle 2 is 42 degrees. We don't know the measure of angle 3, but we know the sum is 180 degrees. So 86 plus 42, that's 128. If we subtract 128 from both sides, we'll have the measure of angle 3, which will give us 52 degrees. And then to determine the measure of angle 4, we know that angle 3 and angle 4 form a linear pair. So 180 degrees minus 52 degrees will give us the measure of angle 4. That'll be 128 degrees.
Again, pause here. Did your method, or is your method what he actually used? What was different? What was the same? Pause the video and talk about that with your partner.
Let's take a look at another example.
Okay, guys, what I'd like you to do here is to copy down this diagram and to do it out yourself. Can you find these missing angles here, here, and then 1 and 2 using only this 124 degree exterior angle and this 95 degree exterior angle? So pause the video, write this all down, and then start the video up again.
This one will go a little bit quicker. We know that the interior and exterior angles form a linear pair, and therefore their sum would be 180 degrees. So 180 minus 124, that's going to give us 56 degrees for this angle here. Over here we'd have 180 degrees minus 95 degrees, that'll be 85 degrees. And then again, we know the sum of the interior angles would be 180 degrees. 56 degrees plus 85 degrees, that's going to be 141 degrees. So 180 minus 141 is going to give us 39 degrees here. And then angles 1 and 2 form a linear pair. So 180 minus 39 is going to give us 141 degrees for angle 2.
Okay, so for the rest of the time here, you're going to do a couple practices on these, and then watch another video on transversals and do a couple more practices on those. I won't be commentating the transversal video, though it's pretty straightforward, but be looking for a lot of vocabulary words that he uses, and kind of maybe the sub can pause the video and say, what was that? What were these? What's this new word that he's talking about?